So guys, it's not matching any one of the options. I just want to go through the formula again. Let's see. So what we have over here is cos squared b we have cos 2b cos 2a. So that's cos squared b minus sin squared b cos squared. Oh, okay. So this does not look right. This should be okay. So this is actually incorrect. It's not correct. Right, let's see. This here should be 2 sine squared and 2 cos squared a, right? So it should be 1 minus 2 sine squared b plus. So what is cos squared b minus sine squared b? That is 1 minus 2 sine squared b plus 2 cos squared a, 2 cos squared a minus 1. That is the expansion for that, right? So minus 2 sine squared plus 2 cos squared. So we should end up with, taking out a 2 there, we should end up with negative here, a positive there, negative, positive. So cos squared minus sine squared, cos squared a minus sine squared b. That should be our answer, which is C. Question number 61. Remember, this is in the this is in the third quadrant. Cos is negative, so negative sine because of the 270 negative sine theta. So negative sine theta on the next page. Right, let's see. Should be negative sine theta. Cot 2a. So to solve for cot 2a, you can say cot 2a is equal to cos 2a over sine 2a. Is equal to cos squared a minus sine squared a over 2 sine a cos a. If you divide both sides, if you want a cot there, if you can divide by sine squared a over divide by sine squared a, what we can get is cos squared divided by sine squared is cot squared a, sine squared divided by sine squared is minus 1 over 2 2 cos a over sine a, which is equal to cot squared a minus 1 over 2 cot a. So your solution is this one, which is A. B, number 63. To solve question 63, we have A is equal to B is equal to 15 degrees. Cot of A plus B. Cot of A plus B. Cot of 15 degrees plus 15 degrees, which is equal to, in other words, cot of 2 times 15 degrees. We have a formula from the previous question, which is 62, which is cot squared. There's your A here, guys. Right, so cot squared 30 degrees minus 1 over 2 cot 30 degrees. which is equal to, what is cot of 30? Let's draw a triangle in the side here for 30 degrees, the special angle, 1 to root 3. So cot of 30 is root 3 of 1, adjacent of opposite. And if we square this, we are getting 3 minus 1 over 2 into root 3 should give me 1 over root 3. Remember that 2 and that 2 cancel out. So 1 over root 3 times 3 over root 3 should give me root 3 over 2. Is there an error in this question, or did I make a mistake here? Let's see. Let's try again. A plus A is equal to B is equal to 15 degrees, and the value of cot of A plus B is equal to, so that is 2 times 15 degrees. Oh, okay, sorry. That should be cot of 30. So actually what we are finding is just cot 30 degrees here. That should be 15. So yeah, that is a mistake here. Only it should be 15. So we can't really use this triangle here. All this should be out. There is a mistake here. Should be cot of 15. Yeah, cot of 15. So this is straightforward. Well, the triangle should remain because now we're finding cot of 30 degrees, which is equal to root 3. So it should be root 3, option A. Question number 64. In question number 64, we're looking at cot of 2A. Here's the question where we can apply that. So you can say cot squared A minus 1 over 2 cot A. So cot squared 30 degrees minus 1 over 2 cot 30. So we can say root 3, that is should be root 3 squared minus 1 over 2 into root 3. We said that and that cancel out. That should be equal to 1 over root 3. 1 over root 3, that is the answer. Sec of 120 is the same thing as saying 1 over cos 120, which is equal to 1 over negative cos 60, which is negative 1 divided by half, which is minus 1 over 1 times 2 over 1, which is minus 2, which will give us minus 2. Sine times cosec, that is just 1, because cosec is 1 over sine theta. Sine and sine cancel out, that is just 1. 1 over cot, that is just equal to tan theta. Said that was equal to tan theta. 68. If sine theta is equal to 3 over 5, then the value of cos theta should be value of cos theta should be 4 over 5. How? We have a triangle which is 3 over 5, which is theta, 4 over 5, cos theta adjacent to hypotenuse. Question number 69. We have sine theta equal to, so what we know is in terms of cos double angle, cos 2 theta is equal to 1 minus 2 sine squared theta. We know that sine squared theta is equal to 1 minus cos 2 theta over 2. Therefore, sine theta is equal to plus minus the square root of 1 minus cos 2 theta over 2. So 1 minus cos 2 theta over 2. The answer is B. Sine 2a over cos 2a. Sine 2a over 2 cos a. What is sine 2a? 2 sine a cos a over 2 cos a. Cancel, cancel, cancel. Sine a. B. If cosec theta is equal to sec theta, then the value of, cosec theta is equal to sec phi, then the value of phi is, so solving this problem, we can say sine theta is equal to cos phi. In other words, it was 1 over sine theta is equal to 1 over cos phi. Of course, we have flipped the ratio or cross multiplied, made an equation. Therefore, we need to see where is sine positive, first quadrant, so quadrant 1. So remember, sine theta is equal to sine of 90 degrees minus phi. You can drop off the sign, therefore phi, which is that is phi is equal to 90 degrees minus theta. Phi is equal to 90 degrees minus theta. Yes, that is phi, or we have another quadrant solution. Where is sine positive second quadrant? So we can say sine theta in quadrant 2. Sine of theta is equal to sine of 90 degrees plus phi. So dropping off the sign on both sides, you got theta is equal to 90 degrees plus phi, which is equal to, so phi is also equal to 90 degrees. Phi is equal to 90 degrees minus phi is equal to 90 degrees minus, let's see, theta minus theta minus 90 degrees. So I would go for option D. What is the value of phi? Or let's try the other options out. Or we can keep, let's say, cos of phi is equal to sine theta, where is cos positive, quadrant 1 and quadrant 4. So of course we are using 270. So cos phi is equal to cos of 90 degrees minus theta, which is therefore phi is equal to 90 degrees minus theta. Okay. Then in quadrant 4 we got cos phi is equal to cos of 270 plus theta. Dropping the cos on both sides, we're getting phi is equal to 270 degrees plus theta. So none of these. So your solution is none of these. In triangle ABC, angle C, sorry, question number 72. In triangle ABC, AB and angle C are given, then the area is equal to half AB sine C. Half AB sine C. 2 cos 75 cos 15. 2 cos 75 degrees cos of 15. Let's say that is 2 sine 15 cos 15. See that? 15 degrees plus 75 degrees equal 90 degrees. For a cos, we got a sine. That's 2 sine 30 degrees. Remember 2 times 15. Double angles. Sorry, no 2 there. Sine of 30, which is equal to half. Right, so question number 74. If cos of alpha is equal to z, so cos alpha is cot alpha is equal to z, so z1, that is square root of z squared plus 1 alpha. Then cos 2 alpha, cos 2 alpha is equal to 2 cos squared alpha minus 1. Cos squared alpha is adjacent over opposite. Z squared over Z squared plus 1 minus 1. So what we have is 2Z squared minus Z squared minus 1 over Z squared plus 1. So what we have is Z squared minus 1 over Z squared plus 1. Looking at cos 2 alpha again, okay, so the solutions does not match up. Looking at alpha again, let's try it again. cos 2 alpha is 2 cos squared alpha minus 1. That is correct. So what we're doing here is we're squaring this adjacent over opposite, all squared. So z squared over z squared plus 1 minus 1. So this was 1 over 1. So we had 2z squared minus z squared minus 1. So we have z squared minus 1 over z squared plus 1. So none of these. As the correct answer is z squared minus 1 over z squared plus 1. Now, the origin is basically 0, 0. So the distance is equal to square root of 4 squared plus 5 squared, square root of 16 plus 25, root 41. Cannot be simplified further. Option A. Vertices of a quadrilateral ABCD are, let's see what type of a quadrilateral. It's good to draw a diagram. So A is here 0, 0. B is 3 and 4. Let me just estimate. That's B. C is 7, 7. 3, 4. I think we go higher up. C is 7, 7. Let's call that C. And D is 4 and 3. So D is somewhere around here. Let's just join these up, right? So, and these, then the quadrilateral ABCD is, what's ABCD? So let us find the gradient of this, which is gradient of BC. Gradient of BC is equal to 7 minus 4, which is 3 over 4. What about the gradient of AD? The gradient of AD, 4 and 3 over 4 as well. Gradient formula is y2 minus y1 over x2 minus x1. Right, so what we know is that these two lines are parallel. What about this way? So coordinates of B was 3 and 4. The coordinates of C was 7, 7. So if I have to find the gradient of CD, 7 minus 3 is 4. 7 minus 4 is 3. And the gradient of AB is equal to 4 over 3. So these lines are also parallel. So guys, so far what we have is a parallelogram. Now a rectangle, rhombus, square are all parallelograms. So what we have is a palm. Now let us find the midpoint. Let's see if this here has a parallelogram has a common midpoint. Let us find a gradient of BD and the gradient of CD. So we can get, if you can get this to be 90 degrees, the intersection from here to there and from there to there, we can say that this is a rhombus. So distance midpoint of BD, which is equal to 7 over midpoint of BD, which is 7 over, let me just write this properly, says midpoint of BD, 7/2, 7/2, which is equal to the midpoint of, sorry, not the midpoint, we are finding a gradient of BD. Gradient of BD is equal to 7/7, which is equal to 1. Sorry, it's not 7/7, 4 minus 3, which is -1. Gradient of BD is -1/1, which is equal to, in other words, we took 3 minus 4 over 4 minus 3, -1. And then the gradient of AC is equal to 7/7, which is equal to 1. Therefore, BD is perpendicular to AC since the gradient M1 times M2 is equal to -1, the product of the gradient. So it will be a rhombus. It cannot be a square because these lines are slant as we drew it on the Cartesian coordinates, Cartesian plane. PQRS, the vertices of a quadrilateral are these PQ, so that's PQRS. The area is, so let's see what type of a quadrilateral this is. Let's insert a diagram. So we can call this R, which is 0, 0, Q03. Q should be here, which is 0, 3, and 5, 0, S, 5, 0. And on the same vertical line, we have P, which is 5 and 3. So guys, this is a rectangle. So you're just going to take the distance from here to there, which is 5, and the distance from there to there, which is 3. 5 times 3 is, we wanted the area, the vertices of its area is 5 times 3, which is 15. So area is equal to just 5 times 3, which is equal to 15 units squared. Sine A is equal to 1/3. Now, this is quite a lengthy one, unless you remember the formula for sine 3A. I can't remember the formula, so let us solve in this manner. 2A plus A. So we have sine 2A cos A plus cos 2A sine A, which is 2 sine A cos squared A, because we're getting 2 sine A cos A times cos A cos squared A, plus 1 minus 2 sine squared A times sine A. Now, this we can draw a diagram there. Sine A is equal to 1/3, 1, 3. That is angle A. This is square root of 9 minus 1, which is 8. So 2 sine A, 2 into 1/3 cos squared A is 8/9 plus 1 minus 2 sine squared A is 1 over 9, and sine A is 1/3. Simplifying this should give me, let's see if you can simplify anything. 2 times 8 is 16 over 27, plus simplifying the inside here, 1 minus 2 over 9 is 7 over 9 times 1/3, which is 16 plus 7, which is 23 over 27. 23 over 27, yes, we do have an answer, which is that. Right, 1 minus 2 sine squared A, that's straightforward, cos 2A. If tan of A over 4 is equal to quarter, the value of tan A is, right, so guys, see, tan let's try tan of A, 2 times A over 2, which is tan A, which is 2 tan A over 2 divided by 1 minus tan squared A over 2. But now we need to know what is tan 2 times A over 4. So which is 2 tan A over 4 minus, remember this is tan A over 2. 1 minus tan squared A over 4. Now we already know what is tan of A over 4, which is quarter. So 2 into quarter over 1 minus quarter squared, 1 over 16, which is equal to half times, remember 1 minus 1 over 16, 15 over 16, so it becomes 16 over 15, which is 8 over 15. You can take this 8 over 15 and substitute it inside here, because we know what is tan of A over 2. So what we can say is, use a different color. Tan of A over 2 is equal to 8 over 15. Therefore, tan of A is equal to 2 into 8 over 15 divided by 1 minus 8 over 15. 8 squared is 64 over 225, which is equal to 16 over 15 times 225 over 225 minus 64. 225 minus 64 should get 161. 16 over 15, or sorry, that can cancel out 1 times and 15 times. So what we have is 16 times 15 over 161. And 16 times 15 we should get is 240 over 161, which is approximately equal to So we're getting 240 over 161. Question number 80, 240 over 161. So guys, question number 80 is an error as no options are available. There's options. Question number 81. So we have sine, cos, sine. So it's expansion for sine. 30 plus 15 is 45 degrees, which is actually 30 plus 15 degrees, which is 45 degrees. Sine of 45 is 1 over root 2. So option B. So we can see this is clearly equal to tan, double angle, tan 2 times 22.5 degrees, tan 45, which is 1. Tan of 13 pi over 12. Tan of 13 pi over 12, you can write as tan of pi plus pi over 12. Now this is in the second quadrant and tan is negative. So sorry, this is in the third quadrant because pi is 180 degrees. So it should just be tan of pi over 12. Converting it into degrees, pi over 12. Remove pi over 6 is 30 degrees. So pi over 12 will be tan of 15 degrees. Now, how are we going to get tan of 15 degrees? Tan of 15 degrees we should get by saying tan of 45 minus 30, which is equal to. So this is expansion for tan. So we got tan 45 minus tan 30 divided by 1 plus tan 45 tan 30. Tan 45 is 1. Tan of 30 degrees is 1 over root 3 divided by 1 plus 1 over root 3. Multiplying by the conjugate, 1 minus 1 over root 3. 1 minus 1 over root 3 should give me an answer which is equal to 1 minus 2 over root 3 plus 1 over 3 divided by 1 minus 1/3, which is equal to 2/3 into 4 over 3 minus 2 over root 3. Let's see, 2 times 4 is 8 over 3 minus 4 over 3 root 3. If I multiply this by root 3 over root 3, I'm going to get 8 over 3 minus 4 root 3 over 3. So I'm getting 8 minus 4 root 3 over 3. Tan 45 is 1. Let's just double check the calculations. Seems like there's a problem here. See, 2 over 4, 2 times 4 is 8, 3 times 3 is 9. 2 times 2 is 4, 3 root 3, that is correct. 8 over 9, that should be, so that should be 12. See, so what we're doing is LCD is 9. Let's take this out from here. Which is equal to, so is this correct? Root 3 over root 3. So what we have is, that's also 9 there. So we can take out 4 as a common factor, 4 over 9 into 2 minus root 3. 4 over 9 into 2 minus root 3. Guys, it's too much of. Right, let's try another technique here. Just looking at the possibilities. Let's not multiply with the conjugate. Let's just try to simplify this as it is. So what we can say is, maybe this was a better idea. Root 3. So we got root 3 minus 1 over root 3 divided by, even though the root 3 is going to go on top, so we have, divided by root 3 plus 1 over root 3. So what we can say, this is equal to root 3 minus 1 over root 3 plus 1 times root 3 minus 1 over root 3 minus 1, which is equal to 3 plus 1 at the end minus 2 root 3 divided by 3 minus 1, which is 2. So 4 minus 2 root 3 over 2, divide everything by 2, you will get 2 minus root 3. So your solution should be 2 minus root 3. In triangle ABC, C minus B cos A over A minus B cos C. Question number 84. In any triangle ABC, so let us attempt to solve this. Good question. So we have C minus B cos A over A minus B cos C. Remember, there's should be a capital C. There's just an error there for the small c. Right. So C minus B was the expansion for cos A. Look at the cos A and the cos C. Cos A is equal to minus A squared B squared plus C squared over 2BC, and this is A minus B into minus C squared, A squared plus B squared, 2AB. You can see we can cancel out the B's here, cancel out the B's here as well. So what we have on top is, also we can take, on the top we can take an LCD there and an LCD here. So what we can say is 2C in the denominator here. It says 2C. This should be 2C squared minus B squared minus C squared plus A squared. And similarly for the bottom over here, we should have 2A on top, and for the denominator, you should have 2a squared minus a squared minus b squared plus c squared. A squared plus b squared minus c squared should be 2. All right, now simplifying this, you see the 2's cancel out. See on the top we have c squared, like terms here, c squared minus b squared, say a squared, a squared plus c squared minus b squared over c times a over a squared plus c squared minus b squared. This and this cancel out, and we have the answer as a over c. So it should be this one, a over c. A difficult question, cos of 18 degrees. So how you can proceed is we can say let theta be equal to 18 degrees. Therefore, 5 theta is equal to 90 degrees. This implies you can break up the 5 theta into 2 theta plus 3 theta is equal to 90 degrees. So 2 theta is equal to 90 degrees minus 3 theta. Taking cos on both sides, cos 2 theta is equal to cos of 90 degrees minus 3 theta, which is equal to cos of 90 degrees minus 3 theta, which is equal to sine 3 theta, which is equal to sine of 2 theta plus theta is equal to sine 2 theta cos theta plus cos 2 theta sine theta, which is equal to 2 sine theta cos squared theta, 2 sine theta cos squared theta plus 1 minus 2 sine squared theta into sine theta. The reason why we're doing this, expanding in terms of sine, 1 minus 2 sine squared theta as well. And this cos squared theta is 1 minus sine squared theta identity. So 2 sine theta minus 2 sine cubed theta. Two sine cubed theta plus sine theta minus 2 sine cubed theta. Therefore, what we have here is bringing everything over. We have 4 sine cubed theta this and this gives us 4 sine cubed theta. Make it equal to 0. So I have the 1 there. Minus 3 sine theta Okay. So maybe it was a bad idea taking a cos there, because what we can have here is, we forgot one more term there, which is minus 2 sine squared theta. So we have a cubic, right? So what we need to try to take out this, and instead of cos, let's switch it to sine. I think that would have been a better idea. Sine, yeah. So let's take this out. Let's try a sine in here, because we are getting stuck with a cubic function. Maybe you can try factorizing that, but maybe this should be. So let us try a sine. Give us cos should give us 2 sine theta cos theta on the side, equal to cos 2 theta cos theta minus sine 2 theta sine theta. So you have 2 sine theta cos theta on the side is equal to, expand everything in terms of cos here. One minus 2 cos squared theta cos theta minus 2 sine theta cos squared theta. So what we have is 2 sine theta cos theta is equal to cos theta minus 2 cos cubed theta minus 2 sine theta into 1 minus sine squared theta So what we have here, okay, should be cos squared theta in here. Let's just leave this as it is. Say minus two sine theta minus 2 sine squared theta. That's where the problem is. Should be 2 sine theta cos theta, so that should be minus 2 cos theta into sine squared theta. So this is minus 2 cos theta into 1 minus. Remember what's the expansion for sine squared theta, which is 1 minus cos squared theta. So if you open this up, you're going to get cos theta minus 2 cos cube theta minus 2 cos theta plus 2 and plus 2 cos cubed theta. Let's just check the expansion again. So what we have here is sine 2 theta is 2 sine theta cos theta. So it became minus 2 cos theta into sine squared theta minus 2 cos theta into 1 minus cos squared theta minus 2 cos theta plus 2 cos cubed theta. Okay, so this is where the problem is. Plus minus plus and a minus there. So plus and a minus there. It's 2 cos squared theta minus 1. the expansion for cos 2 theta is 2 cos squared theta minus 1, which is equal to 4 cos cube theta minus 3 cos theta. And factorizing everything and making it equal to 0, of course, we can take out cos theta as a common factor. So taking out cos theta as a common factor, we have 2 sine theta minus 4 cos squared theta plus 3 is equal to 0. Now we can replace the cos squared theta as 1 minus sine squared theta. Remember, cos theta is equal to 0. Or so we got 2 sine theta minus 4 plus 4 sine squared theta plus 3 is equal to 0. Or that. So you got 2 sine squared theta, 2 sine squared theta oh, we cannot simplify this to be 2 sine squared theta. It should be 4. Should be 4 sine squared theta plus 2 sine theta plus, not plus, minus 1 is equal to 0. Solving this equation. So what we have here is 4. Solving this equation, you can have sine theta is equal to minus b, which is minus 2 plus minus square root of b squared minus 4ac. B squared is 4 minus 4ac should be 16 over 2 times 4, which is equal to 2 plus minus, this is square root of 20. Square root of 20 is 4 times 5, 2 root 5, divided by 2 times 4. So 2's cancel out. You have 1 plus minus root 5 over 2. 1 plus minus, sorry, should be a minus there, minus there. Minus 1 plus minus. Minus 1 plus minus. So it should be minus 1 plus minus square root of 5 over 4. So guys, this is, remember theta was equal to 18 degrees. Therefore, sine squared theta plus cos squared theta is equal to 1. So what we can say is, now we wanted to find sine, or we wanted to go and find cos of 18 degrees. Yeah, so we have found sine 18. Now using this identity, we can recover cos of 18 degrees. So cos squared theta is equal to oh yes, sine of 18 degrees is in the first quadrant, is in quadrant 1. So it should be positive. Sine of 18 should be greater than 0. So the answer should be -1 plus √5 over 4. So we're taking 1 minus 1 minus 1 minus, like this, all squared. So what we can say, this is 1 minus, let's say 16, I'll say 16 minus 1 minus √5 all squared, which is equal to 16 minus 1 minus 2√5 plus 5 over 16, which is equal to 16 minus 1 is 15 plus 5, which is 20 minus 2√5 over 16, which is equal to we want to go and cancel out I think there's something wrong here. Shouldn't be this. Looking at the options. So what we have here is, let's just open this up properly, guys. Oops. Right, so if we open this up, we're going to have 16 minus 1, inside minus 2√5, so outside will be plus 2√5. Inside is plus 5, outside will be minus 5, divided by 16. So 16, 15 minus 5 is 10, plus 2√5, 16. Therefore, taking a square root, cos theta will be square root of 10 plus 2√5 over 4, which is equal to cos of 18 degrees. And that's how we solve cos of 18. First find sine 18 and then manipulate using the identity to find cos of 18 degrees. So we should get, your solution is, so what is your solution? Your solution is 10 plus 2√5 over 4, which is option B. What is the value of k? Question number 86. What is the value of k for which 0.23 lies on the curve? So substitute the value 2 and 3 and solve for k. So it's going to be 4k minus 3 times minus 3 all squared is 9. 9 times minus 3 is minus 27. 2 times 2 is 4. Plus y is minus 3 minus 6 is equal to 0. Therefore, 4k is equal to, see, minus 27 minus 3 is minus 30, minus 30, minus 36, minus 32. Take it over, we're going to get 32. Therefore, k is equal to 8. Question number 87. What we have here is sine 70, sine 50, √3 cos theta. Good question here. Sine 70, sine 50 equals √3 cos theta. So what we can do is divide everything by 2. So what we have here is half sine 70. Or you can divide by 2 or use special angles. Let's just use special angles, which is easier. So let me take out all this. So we have sine of 70, that will give us, what is sine of 70? It will be sine of 90 minus 20 degrees. The reason why I'm using 90 because it's a special angle. Sine of 90 degrees minus 20 degrees plus sine of 30 degrees plus 20 degrees is equal to root 3 cos theta. By simplifying the sine of 90, so you can get sine 90 cos 20 minus cos 90 sine 20 plus sine 30 cos 20 plus cos 30 sine 20 root 3 cos theta. Sine of 90 is 1, cos of 90 is 0, so this part vanishes. That is equal to 0. Sine of 90 is, so we have cos 20, sine 30 is half, plus half cos 20 plus root 3 over 2 sine 20. Root 3 cos theta. So what we have here is 3 over 2 cos 20 plus root 3 over 2 sine 20 is equal to root 3 cos theta. Okay, so this is not actually helping us, so let us try an alternative. Trying an alternative method should help us, or probably preferably using half angles. Just use half angles. So if we think about this as a plus b, so what we can say is a plus b is equal to 70 degrees and a minus b is equal to 50 degrees. 2a is equal to 120, therefore a is equal to 60 degrees. So let us use 60 and 10. Use 60 degrees and 10 degrees. So what we have is sine 70. So we know what our a and b is. So the left hand side of this entire thing over here becomes what happened, or what is the expansion that has sine a plus b plus sine plus sine should give us sine cos. It's a mixture of sine and cos. So this is actually 2 sine a cos b. 2 sine a cos b is equal to root 3 cos theta. Now a is 2 times root 3 over 2. Cos B is cos 10 equal to root 3 cos theta. So 2's cancel out, the root 3 is cancelled out, therefore theta is equal to 10 degrees. Easier method. Question number 88. Cos theta minus root 3 sin theta is equal to 1. I think, yeah, it's a good problem as well. If we divide both sides of the equation by 2, we will have half cos theta minus root 3 over 2 sin theta is equal to half. It's just manipulation. Half we can start off with sine, so you can say sine 30 cos theta minus cos 30 sine theta is equal to half. Next expansion for sine of 30 degrees plus theta. Sine of 30 degrees should be minus theta is equal to half. So this is sine of 30 degrees minus theta is equal to half. So 30 degrees minus theta is also equal to 30 degrees because sine of 30 is half. Therefore, theta is equal to 0. Now, let's see if 0 actually works. So cos of 0 is 1. Yes. Root 3 sine 0, which is 0. So 1 minus 0 is 1. Perfect. Question number 89. In question number 89, change the color of the pen. Tan of B minus C. So let's use tan of B over 2 minus C over 2 times tan A over 2. Let us solve this first. So this is tan of B over 2 minus C over 2 times tan of A over 2. So what we can say here is also note that A over 2 plus B over 2 plus C over 2 is equal to 90 degrees. In other words, A plus B plus C, these are the angles of a triangle, which is equal to 180. So dividing by 2 should give us 90 degrees. Now, tan of B over 2 minus C over 2 times tan of A over 2. So we can say this is tan B over 2 minus tan C over 2 divided by 1 minus tan of, maybe that's not a good idea. Let's use traditional method, which is in terms of sine and cos, sine of B over 2 minus C over 2 for cos of B over 2 minus C over 2 times sine of A over 2 cos of B over 2, which is equal to sine b over 2 cos c over 2 minus cos b over 2 sine c over 2 times sine a over 2 cos b over 2 cos c over 2 plus sine b over 2 sine c over 2, which is equal to